Hello and welcome to everybody on Cloud Fitness. So in today's video, I am going to show you how we can implement Ridge algorithm in pyspark. So in case you have not watched my previous videos on Ridge algorithm, cross validation part, the root mean square error and the multiple videos that I have already placed, I do recommend watching all of them sequentially in order to understand this Ridge algorithm implementation, because if you have not watched those videos, then it will be very difficult to comprehend what I'll be saying in this particular video. So let's move ahead and see exactly how we can implement the Ridge and lasso algorithm in pyspark. Now when I say Ridge and lasso, there is just a one parameter difference that is there, but eventually it's all same. And also remember to subscribe to my channel, like this particular video, and let me know in the comment section if you want me to explain a particular topic, go in depth and explain any particular topic from machine learning. So let's go ahead and see exactly how we can implement Ridge and lasso. So when I say Ridge algorithm, we already know that in case of Ridge algorithm, what we are trying to do is we are just trying to find out the best fit line, right? That is what we are trying to find. Now, if you see this particular graph over here, right? So in case of Ridge algorithm, if you see this red line, now this red line is nothing but it is y is equals to mx plus c, our linear regression line, and Ridge regression is trying to, get you a best fit line which eventually will help you to eliminate the overfitting situation. Now about overfitting also I have explained in my previous videos. Now this green line is nothing but the Ridge regression line which helps you to eliminate the overfitting situation, right? Now in this case, what do we do? To our Ridge regression formula that we have seen, right? To our cost function that we try to minimize, right? In Ridge regression, we try to minimize the cost function. We actually add this lambda, which is nothing but the hyperparameter, and the slope square, right? We try to add this, right? Due to which this green line, you can see that it tilts a bit, right? This is what we are trying to eventually find out in the Ridge regression. Right now, basically, if you see here at the command 22, what I'm trying to do, I'm just simply trying to import few libraries. Now remember that I am using pyspark.ml.regression. From here I am importing the linear regression. I am using ml.feature to import vector assembler. Now this vector assembler also I have explained in my previous videos, right? So if you have 10 features, this vector assembler tries to convert it into a vector into one single column itself, which can be used for your further processing into one single column itself. All your 10 features will be put as a vector in one column through this vector assembler. Then for the evaluation part, I am using the regression evaluator, and for the tuning part, I am using cross validator and param grid builder. Now cross validation also I have made a separate video. Now this is the reason that I have made few theoretical videos before this one. Now if you see, the dataset that I'm using is bostonhousing.csv. Now you can use this particular link to get the file. You can also get this file from the Kaggle as well. I will leave the link in the description box to get the files. Now I have uploaded that file into my file store table, this particular location, and this is what my data looks like. I'm just reading it as a data frame called as data over here. Now you can see it has some set of columns over here, right? It is a bostonhousing.csv dataset that you have. Now here if you see, I am using vector assembler. Now this is what I explained you as well, right? And even for the linear regression, I explained you about the vector assembler. Now these are my input columns, right, that I am providing from my data set. Now these are my features. Now all of these will help me together to find out my output feature, right? So these are all my input columns. Now all these input columns will be made together as a vector. That is why we use this vector assembler. Now you can actually see, after using this vector assembler, right, you will actually see how my data looks like, right? If you look at my final data, right, this is my final data. It looks like, if you see over here, a UDT column, right? Now this UDT is nothing but this is the vector column which has been created using these all input columns. Now similarly, if you see MEDV. Now this is my output feature, right? This will be my output feature that I want to predict using the regression. Now after this part, I will split my data into testing and training. Now this is also one of the part that I have explained earlier, that what we do is we split the data into the training and testing set, right? Now if you see training and testing, I am using random split. 80% of my data is going to the training part and 20% of the data will go for the testing part. After defining this, now here is the point where we are going to define the ridge or the linear or the lasso regression. Now if you remember, I have also created a video on elastic net regression. Now elastic net regression is the one where ridge and lasso both are used, right? If you want to use a combination of ridge and lasso, we call it as a elastic net, right? Now ridge regression, right, lasso regression and elastic net, right? Now these three I have explained in my separate video, theoretical video, where I have explained what these three are and why do we use elastic net, why do we use lasso, why do we use ridge. Now here we are going to set a parameter called as elastic net parameter. If we set it to 0, it will show us that we are using ridge. If we set that parameter to 1, it means we are using lasso. If we set that parameter to 0.5, it means we are using combination of L1 and L2 regularization. So the same code you can write it for the ridge, same code you can write it for the linear, the same code you can write it for the ridge, the same code you can write for lasso, the same code you can write for elastic regression as well, elastic net regression as well, by just setting this particular parameter, which I am going to show you as well. Now here I am using linear regression because I have imported at the top, right? Inside this linear regression, if you see, I am putting in my features. Now if you see over here, this is the features that I have created, right? This is the feature, right? Now I am using all these input columns. I am using it, putting it inside a vector assembler, and then I am naming it as a features, right? Now this is just my features, all my features, which will be used as an input to my data set, right? Now here, when I am importing this linear regression, in the parameters itself I am passing all my features. Label column, this is the output column that I want. This is my output from the model that I want to predict, right? And elastic net param equal to 0. This is what defines that it is a ridge regression. Now I got ridge regression from here. If you want lasso or elastic net, you need to set elastic net parameter over here. Now after doing this, right, what you can actually do is, now I talked about cross validation. Now in case you are not aware about the cross validation, I do recommend watching my previous videos for it. Now for the cross validation, right, we need to get the cross validation done using this cross validator over here, right? And even before this cross validator, right, I need to pass the parameters to my cross validator, right? What my cross validator is going to do, it is going to use some set of input parameters, right? It is going to cross validate my model with regards to the input parameters that I provide, and it is going to give me the best hyperparameter. Now what is the hyperparameter in this case? In this case, the hyperparameter is this value alpha, this value called as your hyperparameter lambda, right? In the case of ridge regression, the lambda is my hyperparameter, right, that I want to tune. So I will use this parameter grid builder, hyperparameter grid builder. Here I am going to say ridge regression dot regression parameter. Now regression parameter is nothing but this is this value of alpha that I want to tune over here. Now I have provided multiple values of alpha, 0.001, 0.01, 0.1 and 1, right? These are the values of alpha that I want to provide. Now here in the evaluator part, how do I want to evaluate my model? Now here also I have made videos on performance metrics. So this is where all of these things comes into picture. Watch all those videos. Now if you see regression evaluator, you can see prediction column, right? I am naming my prediction column as prediction, label column as MEDV because this is the output column that I actually want to predict, and the metric name root mean square, right? I am using root mean square error as my performance metrics, right? So you need to understand all these things in detail before even understanding how I'm trying to do over here. Now in the cross validator, then I'm saying that I want to use ridge regression, right? I want to use these parameters, try to cross validate using these parameters. These are the parameters that I have passed for the alpha. Use this evaluator that I have created over here, because I want to evaluate using root mean square error. I want to get the best value of alpha based on the performance metrics which I have put over here, which is root mean square error. Number of folds 5. Now what is this number of folds 5? You will know it from the cross validations video that I have created, right? So it is going to cross validate it 5 times for each of these values, right? The number of folds is 5 over here. The number of folds, if you want to understand, I do recommend watching the previous video, but even to show you over here, if you see, this is the k fold cross validation that I have explained, right? So in this case, what will happen is, whatever my training data set is, right? Now whatever my data set is, like if I have 100 records, cross validation fold is equal to 5 in this case, right? Even in my case it's 5 that I have shown you. So all will get divided into 5 sets of data. It will get split into the training and the validation data set. That is where theory is very helpful over here. So you will have 16 records going into the validation set and 64 records going into the training set, and it will make sure that each set of data is actually iterated 5 times. So that is 5-fold cross validation. So do watch that video in order to understand more in detail. So this is what is the cross validator part. Now once this is done, right? Now once this is done, I can actually train my model with the best hyperparameters. Now you can actually see cross validator.fit. Now this is where I'm running my cross validator using the training data set that I have created at the top. Now this is where I have my trained data, right? 80% of my data is going to my trained data set. Now after doing all of this, this is where I'm using my cross validator to fit my training data. Now this is where my actually model will get trained on my training data. Now once it gets trained, now this is Spark and I'm using Databricks, so all my models actually get saved here, right? So in the cv.cv, so this is not the case if you are using sklearn or you are using Jupyter notebooks, okay? So their things will get bit different. I will make videos on that as well, because their models are not saved. So this is Spark, this is Databricks, here models are getting saved. So using this cross validator, right, I am using this number of fold 5s and I am putting these many iterations. So using this, all the models will actually get saved in Databricks itself. So from that, I am saying cv.model.best model, give me the best model. Now that model is nothing but my ridge model. So I am getting the best model over here based on the root mean square error and based on these alpha values, that lambda values that I am getting over here, right? Now if you see ridge model.get ridge regression parameter. Now get regression parameter. So if you see, this is the regression parameters, these are the parameters that we have passed. Now out of this, what my model has gave me as the best, it has given me 0.1 as the best value. So my best model has actually used 0.1 value, right? Now similarly, now since it is y is equals to mx plus c line, right, eventually it is nothing but it is just this particular line that we are seeing over here, right? It is supposed to be this green line, right? Y is equals to mx plus c. Now what is the coefficient, what is the intercept, right? That also you can actually get using ridge model dot coefficient, ridge model dot intercept. So all the coefficient and the intercept that you got for the best model, you can actually see it over here, right? So this is nothing but this is how you can actually implement your ridge regression. I hope you like this particular video. Try implementing it, try understanding it, and do watch previous videos to make more sense out of it. In the upcoming videos, we are also going to see logistic regression as well as the other parts as well. So I hope you like this video. Do remember to like, share and subscribe to my channel. Thank you so much for being till here.